Yeah, comes on everyone. The last thing we did was this. Great. Let's go ahead. Let's do a few more questions on this. So we have a circular track like this. If you ever played with that Hot Wheels ka car. It's a smooth surface. So we have a track of radius r. This is 30 degrees. Radius is r. We have a block of mass and release from rest. Comes on everyone. And this was the initial height. So the first question, find h minimum if block reaches the topmost point. So what is the minimum height so that this will complete a vertical circle? Second question, if that height h is 2 times h minimum, so if you are giving 2 times the minimum, find normal reaction. Find speed, normal reaction, and acceleration at a. This would be an advanced paragraph question. The second part. The first part is a mains one. The moment I ask the second one, suddenly it becomes an advanced. So we got a circular track like this. The block is released from height h. The track radius is r. A is at an angle of 30 degrees. First question is find the minimum height required to complete a vertical circle. That's a basic question. Second is a more important one. If you are giving 2 times h minimum, then find the speed, normal reaction, and acceleration at point A. First part is easy. Anyone not clear with the question, please ask. Again, I'll explain the question. Listen, we got a track here. So when this block is released from here, it will come like this. It will go around the circle. So the question is, if the block is released from height h and the radius of the track is r, find the minimum height so that this will complete a circle. That is the first question. Second thing, if this height is 2 times h minimum, then when it reaches to point A, what is the speed? What is the normal reaction? And what is the acceleration? Hope the question is clear. Got an answer, type in the chat box here. The first was easy. That should have got it by now. Look at the first part. Since you're completing the circle, when this block reaches the lowest position, it should have minimum speed root 5 gr. We already derived this in the last session. So if you have at least this much speed, you'll complete a vertical circle. This is state 2. State 1, I'll take the ground as a reference line. Define your energies. Gravitational potential energy, mgh. You're releasing from rest, so kinetic energy, 0. State 2, gravitational potential energy, 0, because you took that as a reference line. Kinetic energy, half mv square. And V minimum is 5 gr, so that is 5 mg r by 2. Energy in state 1 is equal to energy in state 2. Energy is conserved. mgh is equal to 5 mg r by 2. Therefore, the minimum height h minimum is 5 r by 2. So that is 2.5 r. So at least if you have this much height, you'll complete a circle. Hope that is clear. Now, second part of the question is saying I'm giving 2 times of this height. That means I'm giving 5 r. Now find the speed at a normal reaction and acceleration. Speed is root 3 gr. Someone else got root 7 gr. Someone else got root 9 gr. 3 different answers for V part. Try. I'll give another 2 minutes for the V part. So this is your H minimum 2.5 r. I hope everyone got that. Now in the second question, you're saying it is double of this. That means you're giving 5 r. So in the B question, this was 5 r. Find the speed, acceleration, normal reaction at point. Try. 2 minutes. Okay, let's see the speed at least. So this is 30 degrees. So this height will be r sine 30. That is r by 2. And this height will be r. This is my state 1. Gravitational potential energy, mg 5 r. Kinetic energy, 0. You release from rest. This is state 2. So when the block reaches here, this will have some speed v. Gravitational potential energy, mg, height is 3r by 2. Kinetic energy, half mv square. Energy in state 1 is equal to energy in state 2. So we get 5 mgr, 3 mgr by 2, half mv square. Shifted that side, that will be 7 mgr by 2. Is half mv square. V is equal to root 7 gr. Check, that is the speed at point A. N is mg7 minus root 3 by 2. Let's see that. Check it out. That's your velocity. Now find the acceleration and the normal reaction. Try. I'll give another minute. You know that story. The moment I ask you normal reaction, we have to draw an FPD. So if you draw your free body diagram here, this is the block here. What are the forces? Normal reaction. Your mg is this way. This is 30 degrees. So this will be mg sine 30. This would be mg cos 30. Since you're going in a circle, you will have centripetal acceleration, you will have tangential acceleration. A centripetal v square by r, which is 7g. A tangential is g cos 30. There is no other force in that direction. So net acceleration is root over a tangential square plus a centripetal square. You want normal reaction, n plus mg sine 30 is mv square by r or ma centripetal. That would be mv square by r minus mg sine 30, which is 7mg minus mg by 2, 13mg by 2. Check. Most common mistake what people do, they forget a tangential. You need to understand, as you're going up, your speed is decreasing. That is because there is a tangential deceleration. You can even calculate the area tangential. How much is that? 7g square, g root 3 by 2 ka square. You will get something, but okay, you got it. Clear with the steps, everyone. Any doubts on this? Clear enough, Pratik? Devika? Can't see you. Arnav, Abhinav, clear? Taksha? Next thing. Turn in the page. Ariman, clear with this? Ignajit? Surya? Perfect. Next one. This is fixed here. This is a pendulum mass m. This is a string of length L. Exactly below this fixed point, someone placed a nail at a distance x. So this thing is released from rest. Then what will happen? This pendulum will oscillate. And then once it hits this nail, it starts becoming like this. You getting how is the motion? It goes like this. Are you able to visualize what is happening? Once it hits the nail, it starts going in a circle about the nail. That is your nail. This distance is your x. So pendulum is released from horizontal position. The pendulum hits the nail. At a distance x, just below the point of suspension. Find x if it completes a vertical circle. So this thing completes a circle about the nail. Easy question, mostly a mains level one. You will get a range, right? Try. Another 30 seconds. Look at the idea here. Here, you can't change the speed. So this guy, when it is coming till here, at this point, let the speed be v. Initially, it is at rest. State 1, state 2. Loss in potential changes, gain in kinetic energy, you will get v is equal to root 2 gl. Agreed? So now you're saying there is a nail here. If that is x, that means this circle car radius r is L minus x. This is going in a circle. And just now we proved in the last class, for to go in a circle, v speed should be greater than equal to root 5 gr. But your v is root 2 gl, which is root 5 g r. R is L minus x. Square on both sides. We get x must be greater than equal to 3l by 5. So there is a range. So x ka value will lie between L and 3l by 5. You can't be more than L also, no? If you're more than L, it won't hit the nail only. So you have to give a range of answer. 3l by 5 is your minimum value. You can be more than that also. So what you're doing is if you make the circle radius too small, this root 2gl will be greater than the requirement. I hope you're getting it. So the formula is still valid. V minimum is root 5gl, but your R is getting messed up, right? Because of the nail. Clear, everyone? Poroja, got this? Nikhil? Devansh? Clear? Arya? Nadi, clear with this? Next one. This is fixed. This is a light rod. Here we have mass m. Here we have mass 2m. So you kicked this rod with V. And then what happened? This whole rod started going in a circle like this. Be careful, they'll go in different circles. Find V minimum. The length is 12. This is L and this is L. Find the minimum speed. If the rod completes a vertical circle, means you should reach the topmost point. I hope the diagram is clear. We have a light rod and two particles of M and 2M are fixed. We have seen these kind of things multiple times already. You have given speed V to the 2M block. At lowest position. To find that minimum speed so that this completes a vertical circle. You can't use a standard root 4GL formula. That is derived only when there is one single particle. So be careful. Don't randomly use your results without seeing whether the data fits the result. Those results were derived under specific conditions. Okay, you'll get a root, na? Yeah. We have one answer. Not sure whether it is right. Any other answers? What is the catch in the question? The trap in the question is, what is same for both the particles? Speed or omega? They have same omega. They have to cover same angles. So the catch is this. Most people miss out that point. The particles have same omega because the rod rotates the same angle at any instant of time. So if you say, so this thing is going with omega, if this is 2L omega, this is L omega, that means the speed is only half. So when this guy goes to the highest point, since it's at a rod, it can push. This is 2M and this is M. They will just come to rest because it's a rod. Since rod can push, you can have zero speed at the topmost point. So loss in kinetic energy is gain in kinetic energy. So how much height did you gain? So this thing gained a height of 12. This thing gained a height of 4L. Hope you have taken the heights properly. So loss in kinetic energy of 2m v square plus half m v by 2 whole square. Gain in kinetic energy mg 2L. So the block m went 2m and the 2m block went 4L. Please check your calculations. This is mv square plus mv square by 8. That is 10 mgl. This would be 9 mv square by 8. It's 10 mgl. V is equal to 80 by 9 gl. Right, we have. Other secure calculations. See where it went wrong. So this m went to a height of 2L, 2m went to a height of 4L, the difference in height. So initially the speeds are v and v by 2. They both don't go to the same height, both don't have same initial speed. Whenever they say a rod and they say particles are connected, always be careful. Omegas are same, speeds are not same. Another common mistake, people think m speed is 0. That can't happen, right? Rod will start bending. Have a look at this. Ask me if you're confused. Anything that you're not clear, calculation, concept, anything that you're not convinced, please ask. How do we solve if it was a string? We will have a problem with that. String though, then we'll have two conditions here, isn't it? We have to assume this tension is not 0, meaning this centrifugal force is balancing 2 mg. Right? Then you also have to check for this one. And I think if you can keep 2m at rest, m will be automatically at rest. So we need to check for that. At the highest point, start like this. At the highest point, let the speed be v dash and the v dash by 2. Find the tension here T1, find the tension T2. Put T1 greater than 0, put T2 greater than 0. And you see, when you put T1 greater than 0, find what is the velocity. T2 greater than 0, get the velocity. Whichever is a bigger one, you take that guy. Can we just simplify, add the energies? What do you mean by that? Meaning, that is what we did here, conservation of energy. Clear, everyone? Next thing, we have a pendulum here. Let's call this point O. Let this be fixed. This is mass M. This is a string of length L. This would be the vertical circle. It would have gone. Now, what happened? You gave some velocity u. So this thing started going in a circle. Somewhere at this point, tension became 0. After the tension becomes 0, this became like a projectile. It started flying. It went and landed at the point O. It lands on the point of the point fixed point. Find speed u. This does not happen for every speed. The pendulum is given speed u. One thing is for it is definitely less than root 5 gl. The string becomes slack. That is, tension becomes 0. And particle moves in a projectile. And lands at O. find you. String won't bend. You're talking about the previous question? Actually, that is the reason I didn't give the string. A lot of things can be messed up. They can actually have different omegas also if you don't give proper velocities. Is this question clear, everyone? So you gave some speed. This thing didn't complete a circle. Before that, tension became zero. Then it started flying like a projectile. It went and landed on the point of suspension. Then what is the speed? Try. You got 3 minutes. You can give anywhere you want. I'm just giving it the lowest point. So there is no restriction as such, Abhinav. You can give it anywhere you want. But do keep your camera on. If I give you velocity at some other point, then you will take that is your initial state, isn't it? It doesn't matter. Just conservation of energy में initial state change हो जाएगा. Try. You know the drill. T is 0. Start with an FBD there. This is how they'll frame and advance my question. Vertical circle motion plus projectile motion. Try. Just give it a try. I'll get some water and come. Answers. It'll come in roots. Try. Give another 2 minutes. There is a little bit of working involved. Assume initially velocity is u, and from there try to find the range. Can you see this thing? This thing looks like projectile on an inclined. This thing looks like a projectile on an inclined where the range is L. Or you can use like a regular projectile also, but I think incline would be faster. Root GL root 6 plus 1. No, that's not the answer. Let's see the first part. So somewhere here it becomes loose. Let this angle be theta. Let the speed be u. At this point, let the velocity be v. This height will be L cos theta. This would be L. This is state 1. This is state 2. Energy in state 1 is equal to energy in state 2. Initial velocity of mu square, potential energy 0. Finally, velocity of mv square, height is mg, L plus L cos theta. This is equation 1. At this point, if you look at the forces, tension, mg cos theta, centrifugal force. How did you get that? This is mg, this is theta, so that is mg ka components. This was mg sine theta that we don't need. So in this direction, the tensions are tension plus mg cos theta is balanced by your centrifugal force. T is becoming 0. We get v square is equal to gl cos theta. This was your equation 2. Take this and put it in this. M will cancel everywhere. U square by 2 is equal to gl cos theta by 2. L plus L cos theta. So we get U is equal to gl 2 plus 3 cos theta ka root. Check. This is your speed. That's not the answer. Check out the steps here. We still didn't get. We need to find the theta now. I have two variables, theta and u. If I can somehow find the theta, my job's done. So think about it. Now the question has become like this. You're projecting a particle with speed u. This L is the range. This is like an inclined. This range is L. Now, can you do something about it? Root 6 plus 2. I think you got an extra root 2, Rehan. Check out the steps. This is the first part. Now you have to treat it like a projectile and solve. Think, I'll give you another minute or two. And theta 1 by root 2. I don't think so. I think tan theta is root 2. Depends on what is your theta though. You took the same theta. And then maybe you're right, 1 by root 2. Try everyone. One more minute. Let's see. Now look at this. This was O. So at this point, your velocity was U this way, V. V is V, I don't know. That is V, which is I can calculate actually root GL cos theta. This is root GL cos theta. So I will choose this as my x-axis. This is my y-axis. Remember, you have taken this as theta. So if you take mg here, this is theta. So components will be mg sine theta, mg cos theta. That means your acceleration in this direction, ax will be g cos theta. Acceleration in this direction, ay will be g sine theta. And initially velocity ux is 0 and uy is v. So this particle from here is flying and landing at this point. This L is your range. What is time of flight? Time of flight is 2u vertical by a vertical, which is 2v by g sine theta. What is range? Sx is equal to ux time plus half ax t square. Ux is 0, initially horizontal velocity is 0, Sx is L, half ax is g cos theta, t is time of flight square, that is 4v square by g square sine square theta. This would be half GVL cos theta. For V square is GL cos theta by G square sine square theta. L will cancel, G will cancel. We have tan square theta is equal to 2. There, we found tan theta is equal to root 2. If tan theta is root 2, I taught you how to find remaining angles. Opposite side is root 2, base is 1. This is root 3. So we get cos theta is 1 by root 3. Now from the previous question, speed u is root over GL 3, 2 plus 3 cos theta. This is GL 2 plus cos theta is 1 by root 3. GL into 2 plus root 3. Check. This is what makes this question advanced. So first you find the point when the tension is 0, circular motion and NLM. Then you conserve energy, work power energy. And then use projectile on incline. 4 chapters. Check. Any doubts on this? Clear everyone? Vihan, got your mistake? Devansh, Pratik, Puroja, clear with this? Niharika? Ishana, Niharika, got this? Any doubts? Ansh, Ahana? Clear na, Ansh? Daksha? Got this? Abhinav, Arnav, Ariman, clear with this? Great. Next one. So that is about vertical circular motion. So you can see they can ask you a lot of varieties, but you should know your standard results. The next thing is power. So power is rate at which the rate of energy transfer or rate of work done. So when you think about power exactly, like I keep saying, always have a basic idea about stuff. It's not only the technical definitions. So tell me one thing, in real life, what is more important, power or energy? Suppose if you have a 10-floor building, if I ask you to climb the building and come down the building in 1 hour, can you do that? Rehan doesn't want to do it even in 1 hour. He's lazy. Right? The question is not you want to do it or not. Can you do it? Can you climb 10 floor ka building and come down in 1 hour? But same thing, if I tell you to do it in 2 minutes, we have a problem. So think about it. In both the cases, energy is same, right? It is not that energy that is a factor here. It is the amount of energy you can generate. There is a limit. Meaning, to give a simple example, is money important in life? Is money important in life? No, it's a very serious question, right? Chalo, then let's say I will give you 1 crore rupees in next 100 years. Are you happy? Chalo, I'll give you 1 crore in next 10 years. Are you happy? I'll give you 1 crore in next 1 week. Are you happy? Now, if money was actually that important, you should have been happy here also. What was the problem? What changed? It is not money that is important in life. It is money per unit time. Keep that in mind. It is not a philosophical question. Right? People say money is not important. That is bullshit. Money is quite important. But what is more important is a metric. Money per unit time is more important. If money was really important, imagine if I say I'll give you 1 lakh crores in next 1,000 years. You'll say, what bullshit here? I won't even exist till then. What will I do with all that money? See, suddenly so much money became worthless to you. What matters is money per unit time. It was never money. So same way, what matters, right, in real life applications is not energy, but it is the power. How much energy can a machine extract, or how much energy can you deliver per unit time? Based on that, you can see how things, how fast things move. For example, ever seen your bike engine capacities? 100 cc, 200 cc, 400 cc. What is this cc exactly? Thought about it. Cc is cubic centimeters. Cubic is not horsepower, it is cubic centimeters. So what is this volume exactly? That 400 cc is the volume of the engine. So if you have more volume, you can put more fuel inside, you can burn more fuel, you can get more power. So for a bike, when you say 100 cc engine, 200 cc engine, what they're actually describing is the volume of the engine. Getting it? So if you take a bike with 100 cc and if you take a bike with 400 cc engine, the 400 cc ka bike is more powerful. It gives you more power because you can burn more fuel per second. Power here is full. It's not about fuel. It is about how much fuel can you burn per unit time, right? If your engine ka capacity is small c, this is another problem. Ever seen this thing? Ever seen your speedometer? There is a particular range. It says, economy limit. If you go in this range, you get a very good mileage. The problem is in the engine, if you put too much fuel, generally, what do you think? I'm putting too much fuel, so there should be more power, but you're forgetting something. If you fill most of it with fuel, you don't have enough air to burn the fuel, isn't it? To burn that fuel, you need air also. So if you inject too much fuel into the engine, what will happen? There'll be a lot of unburned fuel which will be ejected. So your mileage actually drops. So if you're taking your bike at 80 kilometers per hour, and if you're riding the bike at 40 kilometers per hour, 40 will give you more mileage. For the same 1 liter, you can travel more distance. So that is a basic idea about power. Think of like that. So the definition, power is simply dW by dt. And we know dW is F bar dot dr. We have done this in power method. dr by dt is velocity. So it's a dot product of force and velocity. Units are watts. So 1 watt is 1 joule per second. Sometimes you'll see something in horsepower, which is 746 watts. Sometimes you'll see 1 kilowatt hour. Now you have to be careful. This is not a dimensions of power. This is actually a unit of energy. This is not power. So if you look at 1 kilowatt hour, kilo means 10 power 3. Watt is 1 joule per second. 1 hour is 3600 seconds. So this is actually 3.6 into 10 power 6 joules. So when you consume this much power, we call it 1 unit. In your house, you must have seen this time electricity bill got 300 units, 250 units. So that 1 unit is 1 kilowatt hour. This was a CET level question. What are the dimensions of 1 kilowatt hour? Is it power, energy? Most people think kilowatt, people go, they think it is power, but don't forget there's an into time. If you want to find average power is integral P dt by integral dt, the total energy by time. And if you have a graph, area under PT graph gives you energy. Change in energy. It is work done. Work done is change in energy. Same convention. Area above the, this is negative area. Area above the time axis is positive area. There, this is your main formula for power. Not a big concept as such. There are really not many too much on this, but a few models. Have a look at this. Be careful about that kilowatt hour. It's not a power ka unit. Any doubts on this page? Clear, everyone? Great. Let's see a question. We have a particle projected with u and theta. Gravity is there. Find the power due to gravity at time t. At any time t, what is the power given by the gravity? This is a particle of mass m. Projected with u and theta. Didn't you get a minus sign? Straightforward. What is power? F bar dot V bar. you should know your results of this projectile motion. So here, force due to gravity minus mg j cap. What is velocity vector? Horizontal velocity vx I cap plus vy j cap. What is vx? U cos theta I cap plus u sin theta minus gt j cap. You're done. So what is power? F bar dot v bar, which is minus mg u sin theta minus gt. Easy. Know your velocity, you know your force, you're done. Next one. Any doubts on this? Clear now, Vajas? Surya, clear with this? Ariman, got this? Next one. Clear now, Ariman? Let's say we have a building here. Here on top of it, we got a pump. So this is all water here. So what this pump does, it takes water from this well or this from bottom here, and it sprays out this water. So it is spraying out water at a rate of 10 meter per second, at a rate of 10 kg per second. And it is taking water from a height of 10 meters. So this pump takes water from a height of depth of 10 meters and throws out 10 kgs per second with a speed of 10 meters per second. I kept everything 10. The water pump takes water from a depth of 10 meters and pushes out 10 kg per second water, speed 10 meters per second. If the efficiency of the pump is only 40%, what is efficiency? Power output by power input. Means whatever electricity you're supplying to this pump, in that only 40% is used to pump the water. Find the power supplied to the pump, meaning how much electricity are you giving to the pump. Hmm. 250, nope. See now. So how much potential energy are you taking per second? So potential energy per second is mass per second into GH. That is 10 kgs per second. Gravity is 10. Height is also 10. So the pump is supplying 1000 joules per second for potential energy. Kinetic energy per second is half. Again, mass per second into V square. This is half 10, 10 square. So you're supplying 500 joules for kinetic energy and 1000 for this thing. So the total output is potential plus kinetic. So the pump is giving output of 1500 joules per second. So efficiency is what? Output. Now, he didn't ask you for output, he's asking for input. How much did you give to the machine? So this is 40, output is 1500. So machine, it takes something and it is giving out 1500 eventually into 100. This would be 3750 joules per second. Or you can write 3.75 kilowatts. Check. So 1500 is your output. So 40% efficiency. So 40% of input is 1500. Clear, everyone? Easy? The questions are not tough, but you should know that, what is being asked in the language. No, it's not kilowatt hours, so power it is. Next one. Clear, na, Daksha? Ansh, you look tired today. Exhausted. Next thing. A vehicle of mass m has constant power P. This is a standard question, right? Meaning mains or NEET or CET level question, meaning asked multiple times, you can expect again. Starting from rest. Find velocity and the position is function of time t. Right, Vihan. Meaning, just to give an idea, power is force into velocity. Force is mass into acceleration. Acceleration is dv by dt. There you have to integrate. Get it? Then once you got v as a function of time t, again integrate. It's just double integration. There's nothing there. Right, Arya. Head RA1. Get the position also. Yeah, let's see. So if integrate this, VdV is equal to P by MT. Integrate 0 to V, 0 to T. We get V square by 2 is equal to PT by M. V is equal to root over 2 PT by M. Integrate this again. T power 3 by 2 by 3 by 2. So this was asked in the question, V is proportional to what T power half? X is proportional to what 3 by 2? Check. Easy. Just a double integration there. Suppose if power is not constant and they say P is equal to T, then what will change? This will be T here, na? Integration will be T dt. Clear? Just have a look at this. Someone is ringing the bell. Yeah. Some Amazon guy. Next one, let's see a theoretical question. Let's say we have a windmill. No, that doesn't look like a windmill, but yeah. Looks so weird, right? Okay. This is better. Whatever it is, doesn't matter. So we have a wind blowing here. Blowing with speed V. Rho is the density of air. So the question will be like this. Find the power generated by the windmill is proportional to V power X. Find X. I don't want the exact value. So the question would be something like this. If the speed doubles, how much more power will you get in a windmill? V is the speed of the wind. See, one thing everyone knows, the faster the wind blows, more power you get. But exactly what is the relation? Let me help you. Can I say like this? All the wind in this cylindrical cone, which is hitting this, is responsible for the power generation. So let this area of cross section be A. So in this cross section, take a small slice dx. So the mass of the wind in this small slice is density of air into volume. How much is the volume? Density of air, A into dx. So in this small section, what is the kinetic energy? Half dm v square. What is power? D energy by dt. So this is half dm by dt v square. But what is dm by dt? Rho a dx by dt. But what is dx by dt? Velocity. Half rho v cube. So proportional to cube function. So basically what is happening is when this wind is hitting it, every second this dm mass is hitting the windmill at dt time, isn't it? So the total energy extracted per second, it will not be exactly equal to, because there is an inefficiency also. So there will be some factor. But fine, anyway, we just wanted proportionality. This would be the answer if it is 100% efficiency. But we know when the wind comes out, doesn't come with zero speed, and wind does escape between these things. In this case, we are assuming all the kinetic energy of the wind is becoming into energy. But like I said, it will not be 100% efficiency, right? So it will be like maybe 5% of that becomes this. But still, proportionality will be still V cube. Making sense? So if it is 5%, then you will say 1 by 20th of this. Yeah, you can say the same thing for the water also. Water will be even better, isn't it? The rho will be bigger. The rho of water is bigger. Right, Vihan? Air is only how much? Air density is 1.3 kg per meter cube. Water is 1000. So that means when if you put a wind water turbine in a hydroelectric power plant, that produces almost 500, 600 times more power than wind. Easy? Everyone got the concept? A good theoretical question. Let's say we have a curved surface like this. Y is equal to x cubed by 3. Have a block of 10 kg going with a constant speed of 10 meters per second. This is 0, 0. Friction is equal to half. Find the power due to friction at x is equal to 1. We have done this in circular motion, if you remember. This was the last question in circular motion. Try. So this block is sliding on a curved surface. Whose equation is x cubed by 3. Find the power due to friction at x is equal to 1. Anyone remembers this? Here we have seen this. Isn't this the same question? Didn't we find how to find the friction here? If you know friction, can't you find power? Friction into velocity. Done. Exact same question. We have to use radius of curvature. That is the sad part. You guys didn't even remember that we did something like this. So how do we do this? So at x is equal to 1, drop a tangent. So slope tan theta is dy by dx, which is x square. At x is equal to 1, tan theta is equal to 1, and theta is 45 degrees. So it behaves like an incline of 45 degrees. So when the block is here, the forces are mg cos 45, normal reaction, friction, maximum. There is some external force acting here, which we are not showing. Mg sine 45. So the catch in the question was this: since it is going in a curve, it's like going in a circle. There is a centripetal acceleration, which is v square by r. That's what most people forget. So your normal reaction is mg cos 45 plus mv square by r. How do you find r? We use the radius of curvature, 1 plus dy by dx whole square, 3 by 2 by double differential. And when you differentiate this, you end up with 1 plus x power 4, 3 by 2 by 2x. Substitute here, that will be root 2. We will get 100 by root 2 plus 1000 by root 2. N is 1100 by root 2. Friction is mu n, which is 550 by root 2. Power is minus F into velocity, both are opposite. Minus 5500 by root 2 watts. Entire question is same. Only thing you have to multiply with V in the end. Don't forget this pretty good question. There you have your NLM, you have friction, you have circular motion, you have work per energy. All 4 chapters are there. Clear with this? With that, you're done with the chapter. So you can start working on this, finish it off. And like I said, for this week, today is the last class. We don't have a class on Thursday. And again, next week we are on a break due to Diwali. So directly we'll catch up again on November 5th. So you do have a break. So do use this time, to cover up your backlog if you have any, but also make sure I'm sure, classes also must be getting 1 week break now. So do plan a trip. If you're going somewhere, please make sure to plan 4-5 days, go out somewhere. This is for people who are studying every day. If you're not studying every day, you're doing time pass every day, please use this time to cover up your backlogs. But there are some of you who are actually studying every day and doing your work.